Now we will set up Spring WebFlux 5 project and we will build reactive endpoints. So the prerequisite for this project will be Java 17 and Gradle 7. I have opened a site called start.spring.io. It's a Spring initializer where we can create a project from the scratch by choosing the type of the project, whether we want Gradle or Maven. We can choose the language. We can choose the Spring Boot version. Right? We can give the name of our choice. We can choose the packaging, jar or war, or the Java version, and we can add the dependencies already provided by the Spring, so that uh, at the at the time of the build, all those dependencies are pulled in your local cache. So we will create a Gradle Kotlin project. We will choose the language as Java. We will choose Spring Boot version at 2.7.0. We are going to create a video collection uh, microservice which manages all the videos. So we can perform CRUD operations with this microservice. Now we can add the dependencies. So we will use Lombok to uh, which is a library that helps to reduce the boilerplate code, especially in Pojo. And we will use the MongoDB. So we will use the reactive one. Also for the test cases, we will use embedded MongoDB, and we will use WebFlux as the reactive for the reactive web application. So if we click on generate, it will download the project as a zip. So I've already downloaded in my download folder. So I've already imported the video collection project in the IntelliJ, and I have run a task that is Gradle build that will build the project, and it will download all the dependencies from the Maven central repository. So a I've created a package called controller, which has a class video controller in it, and video controller is nothing but a REST controller. I have defined a request mapping with the value as slash videos. There are two REST APIs. One is get one video and other is get all videos. So get one video returns a mono of video, i.e. only one video, and get all videos return a flux of videos. So to make the endpoint reactive, the return type of these methods are mono and flux respectively. So I have created a video using builder pattern, and the ID is same as the ID coming in the path variable of the request URL. I have used the annotation path variable to store the ID coming in the path variable in the variable ID. I have used the method mono.just to create the mono publisher. I have used flux.range to create a flux of elements starting from 1 to 5, and using the map operator, all those values are converted to create the videos using builder pattern with the ID as the count value, and all the videos are returned as a flux of data. Video is nothing but a Pojo, simple Pojo having the property name. I've used Lombok to reduce the boilerplate codes. So let's run this application. So the application has been started successfully on the port 8080, and the embedded NetEase server is used. We can test our reactive endpoints with the help of Postman. So in the Postman, we have the first and reactive endpoint, that is get a video. So I'm calling localhost 8080, the videos endpoint, with the path variable as 1. Now if I send the request, I will get a response video 1. And to get all the videos, I'm again calling the same endpoint without the path variable. If I send the request, all the videos, video 1, 2, 3 till 5 is returned. So we have successfully set up our Spring WebFlux project 5, and we have built our reactive endpoints. Now let's learn about the project reactor operators. to understand the operators, we have the visual representation. That is what we call marble diagram. So in the marble diagram, the data stream is represented by a line starting on the left side from the publisher and on the right side with the arrow ending to the subscriber. All the data elements are represented on the data stream with a complete signal. The operator is represented by a box. So suppose if we are taking the operator that is filter operator, it will convert the data stream into a different stream that is represented by the next line. Now the filter operator takes the predicate. Now the predicate says that if the object is circle, it's allowed to pass. Now the first element, that is a circle, to is allowed to pass through the operator. The second element, that is a square, is not allowed. Again, the third data, that is a circle, is allowed, and the rest of the data or the events are not allowed to pass through the operator filter. And finally, the on completion event is allowed to pass through the operator. Now let's see another uh, operator, that is map operator, that will convert the stream into another stream by mapping one object into the other. So in the map operator, we are converting circle to the red circle. We are changing the color of the circle. So now the first data, that is circle, gets converted into the red color, and the second data is also getting converted into the red color. And finally, the on completion event is allowed to pass through the map operator onto the new stream. Now we will see operator types. So there are tons of operators that we can use and that are separated into various categories. We can create the data streams, we can peek into them, we can split them, we can filter them, we can introduce error handlings and turn the reactive operations into synchronous ones. We can transform them, we can manipulate them, and we can multicast data to multiple subscribers as well. But we will focus mainly on the highlighted operator types. Now let's see how many types of operators we have that falls under the create category. So we have total 24 operators, and we have already seen two of them.